Okay, can we get started? Can we get started?
Yes.
Okay, so today I want us to cover a couple of things today. I want us to look at past questions that will be relating to pH calculations. I want us to be looking at oxidation number calculations as well as calculations in molar calculation. Okay, so I want us to cover a whole lot. I want us to be fast. Are we okay on this? Are we okay on this?
Yes, sir.
Yes.
Okay, so let's quickly look at what acids are so that with that we can relate them to our pH calculations. So acids, we normally recognize them with their sour taste. They typically taste like unripe fruits, and they have this ability to turn blue litmus red. Okay. So when acids dissolve in water, they are ionized, producing hydrogen. These are positive ions called protons or hydrozonium ions. Okay. Physical states of acids, dilute acid turn blue litmus paper red, like I said before. Concentrated acids are corrosive in nature. Corrosive, when you touch them, the effect is very bad on the hand. Dilute acid have sour taste, and they produce hydrogen positive ion, which are what we are going to be looking at when we are looking at pH calculations, which is what we are going to be looking at. The way we will structure our classes is that we are looking at the exam that you're likely to write. So as we are teaching, we want you to get closer to what you expected to see in your exam, which is what we're looking at, okay? So what are the chemical properties of acid? Metals above hydrogen in the activity series will react with dilute acid to form metallic salt, okay? Bases are oxidized and hydroxides to metals. So we're going to be looking at all these with metallic. They have their own reaction with metallic triisocarbonates as well. Okay, I don't want us to dwell much on the notes. Okay, then what are bases? A base is a compound which will neutralize acids and will turn red litmus paper blue. So bases are usually metallic oxides and metallic hydroxides. Some of the physical properties of bases are on alkalis. Sometimes you hear the word alkalis. The bases have bitter taste. Solution of alkalis will turn red litmus paper blue. This is unlike what I mentioned before, that for acid, it will turn blue litmus red. For bases, they turn red litmus blue. The solution of alkalis have soapy feel. Okay, so we also have chemical properties of bases and alkalis. Most importantly, their reaction with acid, like we know. So when they react, we have what we call neutralization reaction, producing salt and water. Okay, so let's quickly look at similar problems that we can have in pH calculation. Okay, so calculation of pH. Chika, are you following?
Yes, sir.
Okay. So I want this class to be very fast so that we can be able to cover these three. So let's look at this question number 18 from Jamb Chemistry 2016. The color of litmus in an alkaline medium is. So what's the color of litmus in an alkaline medium? Alkalis are basic hydroxide, which are soluble in water. They have bitter taste and they turn red litmus blue. You can see this is actually covered in what I said so far already from the
It's
brief class
blue.
we had. The answer is blue, isn't it?
Yes.
Okay. So let's look at number 2 question. Calculate the pH of a solution of
But I'm not seeing the question.
0.001 mole per dm cube. Oh, sorry, please. Okay. Please tell me when you can see the question.
I can see it now.
I can see the question now.
Okay, good. So this question number 1, Jamb 2016, chemistry question number 1. So question number 18, sorry. So these are some problems from past question. Like we all know, our training here is directed to our passing our exams. So we'll quickly look at similar questions in our past question. So we have the color of litmus in an alkaline medium is option A, red, B, yellow, C, pink, D, blue.
D, blue.
So what do we think is the answer from what I say? Okay, is blue
D,
because
blue.
alkalis are basic hydroxide. We already looked at this in the class we just had now, which is soluble in water. So alkalis are bases that are soluble in water. They have bitter taste and they turn red litmus blue. So option D is the right answer. Okay. Now let's look at question number 2. Calculate the pH of a solution of 0.001 mole per dm cube hydrochloric acid. So the answer 2, is it 4, is it 3, is it 1? So when you have these hydrochloric, when it's hydrolyzed, we have 1 hydrogen ion and 1 chlorine ion. So the concentration of this H ion, once what is in front of it is 1, then what you have here should also be the concentration of the H here. And that's why we are having 0.001. So for each one contains 10 to the power minus 4. Okay, so that this very 0.001, if you convert it to standard form, you're going to have this. You move this point here, you have 1, 2, 3, 4. So it's 1 times 10 to the power minus 4. That is what this concentration is. So our pH is equal to, like we all know, the pH is simply the negative logarithm of the hydrogen ion. So this is the negative logarithm of the hydrogen ion. So this concentration, like I said, this contains this very, this is the concentration. This is what it contains. This is the concentration of the hydrogen ion. So we'll put this very standard form here so that we can manipulate this logarithmic expression. Okay. So when you have log to base 10 of 10 to the power minus 4, you simply take this minus 4 to the back so that you now have log 10 to base 10, which is 1. So this is negative 4 and we have negative here. So negative times negative gives you positive. So taking this 4 here gives you this 4. And that is why option B is the answer. I don't know whether you understand this, Chika, or do we go through it again?
So please go through it again.
Okay, so pH is simply the negative logarithm of the hydrogen ion.
Okay.
Negative logarithm of the concentration of the hydrogen ion. And how do you get to know the concentration? You get to know the concentration from how it is stated in the question. Here we have calculated the pH of a solution of 0.001 mole per dm cube. Okay, so first of all, when you write this equation where you have the HCl in a solution, so you have H, which is the positive ion, and you have the chlorine. So how do you know the concentration of the hydrogen? So once you balance this equation, you see that HCl, there should be one here that is not written, and there should be one here and also
I'm
one.
not sure. I don't know.
That means if we have 20 of these, we are going to have 20 of these.
Hey, Lisa. No, she's not here with me now. With my
Hello?
sister. Okay, so I'll call you back. Bye-bye.
Okay. Okay, so since we have one here, we have one, and we have one here. So that means if we are having 20 mole per dm cube here, we're also going to be having 20 here, and we're going to be having 20 here. But what we're having here is 0.001
Okay,
mole
so
per dm cube. Okay, so that is what we also have of the concentration of the hydrogen ion. So you convert this very 0.001 into a standard form, take it into a standard form, so that when you take the negative log reading, you can easily manipulate it. So how do you convert this to a standard form? You simply count the number of zeros you can get through here. You have 1, 2, 3, 4. So this is the same thing as saying 1 times 10 to the power minus 4. So, and the pH is simply the negative logarithm of the hydrogen ion. And that is what is here. So what is the concentration of this hydrogen ion? It's 1 times 10 to the power minus 4. Okay. So you take this 4 here, minus 4 down here. So we have negative times negative, so that you have plus 4. And when you have log 10 to base 10, you have 1. So the answer is 4.0. Johnson, Ojo, do you understand this?
Yes, yes.
Is it clear?
but
Yes.
Okay. Yeah.
we have like other formulas in this pH log. How will you know when to use the specified formula?
Okay. So whenever you ask the pH, that's when you use this very one. But maybe subsequently, when we see other questions, you will see the way we also approach that. But once you're asked pH itself, pH is simply the negative logarithm of the hydrogen. Okay.
Okay,
But
sir.
we still see other problems. When we see them, you see the approach that we're going to be taking. Okay, so we have another question here. Jamb 2014 chemistry. The color of litmus in a neutral medium is. So we have purple, pink, yellow, orange. Litmus is an indicator that it produces different color in solutions according to the hydrogen ion concentration in that solution. So we have mostly red turning into acidic solution. You can get purple in a neutral solution, and you can get blue in an alkaline solution. So if you see something like this, you can pick a purple color for this. Are we okay on this?
Yes.
Okay. So let's quickly get to more questions. Okay. Let's look at these molar concentration problems. Okay. So let's, I'll quickly take us in let's quickly check out oxidation. So class, do we know what oxidation is? Can tell me what oxidation is? So Johnson, can you help us with what oxidation is or what reduction is?
Okay, sir.
Okay.
Oxidation is the loss of electrons during a reaction by a molecule, sir.
Okay, yeah. That's very good. Very nice attempt. So oxidation may be defined as the addition of oxygen.
Yes.
Another way of defining it is the removal of hydrogen.
Okay, sir.
Example is the action of hydrogen sulfide and chlorine. Hydrogen sulfide is oxidized by the removal of hydrogen from the hydrogen sulfide to form yellow deposits of sulfur.
Okay.
And reduction is actually the opposite of what happens in oxidation. So in reduction, you have the opposite of what happens in oxidation. So in oxidation problems, you normally solve problems in oxidation numbers, and I would like us to see a little bit of that so that as we go into more details in oxidation, we'll be able to understand these. So let's look at some problems that we have in past questions on this. Can you see the question that I have up there? Yeah, Johnson, can you see the past questions that are out there?
Yes, sir. Yes, sir. The oxidation number of iodine in...
Okay, so we have in KiO3 is what, isn't it?
Yeah. Yes.
So we have option A, +7, +3, +5, and +6. Now, in every compound, every neutral compound, you understand, the summation of the oxidation number is 0. That's the first thing you take note of. So you have these are KiO3. So we have the summation of what is the oxidation number of the potassium, the iodine, and the oxygen. So if you sum the oxidation numbers, you're supposed to get 0. So make sure that you equate the sum of the oxidation numbers to 0. Then once you do the calculation, you should be able to get the oxidation number of what you're looking for. Then whenever you're doing calculations in oxidation numbers, it's very, very important that you know that when, let's say you want to calculate for that of iodine, they expect you to have known the oxidation number of, say, potassium, that of oxygen, isn't it?
Yes.
And these numbers are numbers that you know about because you know about their valencies. So what's the valency of potassium? Is +1. And what is that for? What is the valency of oxygen? Is -2. So if you come to this, you have to substitute the values here. So for K, you have 1, whereas for O, you have -2. So how many oxygen molecules are we having? We are having what? 3 of them. So you have 3 times -2, whereas here you're having 1. So 3 times -2 is what? -5. I mean, -6. So 3 times 2 is 6. So we have -6 here. So if you now say 1 minus 6, you have -5. So when you take the -5 over to this other side, you have +5. That is how we come about this +5. I don't know whether it is clear to you.
Yeah, it's clear, sir.
Yeah. Okay, Chika, it's like you went out.
Yes, sorry, sir. My distance cut off.
Are you back?
Yes, sir.
Is it your network?
Yes.
Okay, so we are looking at briefly what oxidation. Huh? Okay, we are looking at what oxidation and reduction is so that we can easily do calculations in oxidation number. We say that oxidation is the addition of oxygen or the removal of hydrogen. And we are looking at this simple calculation. The oxidation number of iodine in KiO3 is it +7, +3, +5, or +6? So like I said, you're supposed to know the valencies of the major or the most common elements like potassium, oxygen. Okay. So from there, the oxidation number of potassium is +1, that of oxygen is -2. So the summation of the oxidation numbers of the elements in a neutral compound is normally 0. So we have K plus
I plus
the potassium plus oxidation number of the potassium plus that of the iodine plus that of the oxygen. So oxygen, the oxidation number is -2, and there are 3 atoms here. So we have 3 times 2, which is 6.
Yeah.
So because of this negative, we are supposed to have -6. So 1 here -6 will give us -5. So making the I the subject, you have to take the -5 over to this side, make it +5. And that's why we'll have +5 to be the answer. Okay. Are we clear on this?
Yes, sir.
Okay, so let's move down to the next one. So we have here the oxidation number of boron in sodium. You have this sodium, this boron, and these 4 atoms of hydrogen. So what is the oxidation number of boron in this? Okay, so we have sodium. What is the oxidation number of sodium? Is 1.
Yes.
So this is the boron here.
Yeah.
And this is this hydrogen, -1.
Yeah.
So you have 4 times -1, making it -4. You have this one here, 1 minus 3.
Yeah.
That is -3. So you have B -3. Taking this 3 over to this side, you have +3. I don't know whether this one is clear.
And the only issue is how you arrived at
Dr. Johnson,
that,
is it clear?
no, how you arrive at that +3. You said
At the +3, but
yes.
okay. So we have 1 here. Sodium, the valency of sodium is 1.
Yes.
That clear? So
Yes.
these are sodium tetrahydroborate, isn't it?
Yes, sir.
So this is 1 here. So we'll write that of 1 for the sodium. And boron is the one we are looking for. So we'll write B. And this hydrogen, we have 4 of it.
Okay.
So that's why we have 4 times -1.
Okay.
Okay. So
Yes,
if you
sir.
say 4 times this, we have -4. So if you now do this 1 minus this -4, you have -3. So -3 going over to this side gives you +3.
Okay.
Is it clear?
Yes, sir.
Okay. So I'm going to send these. I'm going to send these to the WhatsApp group so that you take a look at them. If you have any questions, further problems, questions on them, you can ask me. Okay. In the reaction above, the substance that is being reduced is. So which substance is being reduced here? So reduction is a reaction in which oxygen is removed from a substance or in which hydrogen is added to that substance. So in the reaction above, F2 was reduced because hydrogen from water is was added to it. Okay. So you can see that here now. What we defined earlier in this class, we defined what oxidation is, isn't it? Say that oxidation is the addition of oxygen.
Yes.
Isn't it?
Yes.
Or the removal of hydrogen. Whereas reduction is the removal of oxygen and the addition of hydrogen. So you can see that this fluorine was not having hydrogen here, but here is now having hydrogen. So it has been reduced. Is it clear?
Yes, sir.
Okay. So reduction in a reaction is a reaction in which oxygen has been removed. So when you have oxygen removed from any compound, then we're talking about reduction. Or in another case, if you have hydrogen being added to that very compound, that has also been reduced. So fluorine here has hydrogen added to it, so it is reduced. Okay, so we're going to sign off now so that everybody will get set. I'm going to send this to our WhatsApp group so that we have it and we can move forward. So Chika, what's happening?
Sandy just brought the light.
Chika, you're logging on and off. Wow.
That is the Wi-Fi.
Is it light?
Yes. I'll be on the phone.
Okay, the Wi-Fi is giving you. Okay.
Yeah.
So please, I want you to look at these calculations and try
Oxidation
to
number.
understand them.
Yes, sir.
But I'll send them to your WhatsApp now, okay?
Okay, sir.
Yes, I'll send them to your WhatsApp. So, in summary, we looked at oxidation. We said that oxidation is the addition of oxygen or the removal of hydrogen, whereas reduction is the removal of hydrogen and the addition of the removal of oxygen and the addition of hydrogen. So we looked at basic calculations in oxidation. Yeah. So these are basic calculations in oxidation number. So whenever you're given oxidation number calculation to do, always equate the summation of the various oxidation numbers of the component elements of the compound, equate the sum to 0. Okay.
Okay.
So, and mostly in most of the calculations that you're given, you're going to be given these elements like potassium that you know that the valency is 1, oxygen that you know it is -2. So those are the ones that, so you just substitute those values. So for potassium now it's 1 plus you have iodine, which is what you're looking for, then plus these are 3 atoms of oxygen. That's why we're having 3 times -2, which is the oxidation number. So equal to 0. So you sort it out. You have 3 times -2 is -6. So when you now do this 1 -6, you have -5. So take it to the other side to make I the subject. So you have +5. That is how we came about that. Did you understand that?
Yes, sir.
Okay. So similar thing was done here for this sodium tetrahydroborate. So for sodium is 1, then plus B, which is the boron we are looking for. And the oxygen here is -1. So we have 4 times -1. So we have 1 minus 4, which is -3. Taking it over to the other side becomes +3. And in this one, we are asked, in the reaction above, the substance that is being reduced is what? So we know that reduction is simply the addition of hydrogen. So you can see that this fluorine here that was on its own, this other in the reactant side, it now has hydrogen. So that means it has been reduced. That is why option C is the answer, because reduction is a reaction in which oxygen is removed from a substance or in which hydrogen was added to a substance. So in the reaction above, the fluorine molecule was reduced because hydrogen from H2O was actually added to it. Chika, is it clear?
That is a bit clear. I'm not really sure.
Okay. So do I go about it again?
Yes, sir. So here it is the water that is undergoing
Okay.
the reduction.
So here, okay, for this last one, okay?
Yes, sir. Is that it? Is it the water that is going reduction?
Okay, so, so reduction is the addition of hydrogen. Are you clear on that first?
Yes, sir. Yes, sir.
Reduction can be seen as the addition of hydrogen or the removal of oxygen, while oxidation is seen as the addition of oxygen or the removal of hydrogen. So since this problem is all about reduction, so we are looking at where hydrogen is added. So the fluorine here does not have any hydrogen, but here is having hydrogen. So there is addition of hydrogen to fluorine, and that makes it that fluorine is being reduced. Because the question is asking you, which in the reaction above, the substance that is being reduced is what?
It's fluorine.
Good. Hydrogen fluoride, because hydrogen has been added to this fluorine. So what hydrogen does is reduction. So anywhere hydrogen is going to newly is actually causing reduction to that very place. Whereas anywhere oxygen is going, oxygen is causing oxidation. Oxidation is the opposite of reduction. Yeah. So are you clear on that?
Yes, sir.
Okay. So I'm gonna quickly send this to your WhatsApp so that we can communicate more there.